In the world of military operations, the stakes are just incredibly high. A single loose bolt, a tiny microscopic crack, that can literally be the difference between a successful mission and a total disaster. But imagine if that same piece of equipment could kind of whisper a warning, tell you it was about to fail before it actually happened. Well, that's not science fiction anymore. Today, we're going to dive into the tech revolution that's making this a reality: AI-driven predictive maintenance.
All right, so here's the plan. First up, we're going to look at why the old way of doing things, fix it when it breaks, just doesn't cut it anymore. Then we'll get into the cool stuff, how AI is basically becoming a digital crystal ball for military gear. We'll even jump to the front lines, air, land, and sea, to see it in action. After that, we got to talk about the big payoffs, but also some of the serious risks. And finally, we'll look at the roadmap for what this proactive future really looks like.
Okay, so to really get why this shift is such a game changer, we have to start with the problem itself. Let's be real. Military hardware isn't just used, it is punished. It's pushed to the absolute breaking point in the harshest conditions you can imagine. Brutal combat, corrosive salt water, you name it. And the old ways of keeping all that gear running, well, they're just getting completely overwhelmed. Just think about that for a second. An entire mission, and more importantly, the lives of everyone on it, could be put on the line because of one single unexpected mechanical failure. In that kind of world, there is absolutely zero room for guesswork. So for the longest time, the military has been stuck between a rock and a hard place, with two flawed options. Option one is what we call reactive maintenance. Basically, you just wait for something to break. And in the middle of a mission, it's catastrophic. Option two is scheduled maintenance, but that's really just an educated guess, right? You're either wasting a ton of time and money replacing parts that are perfectly fine, or you're just crossing your fingers and hoping a critical component doesn't decide to fail the day before its scheduled checkup. So the bottom line here, neither approach is smart enough, and frankly, neither is safe enough.
Okay, so this is where a much smarter way of thinking comes into play. We're talking about a total paradigm shift here, moving away from just reacting or guessing and toward actively predicting what's going to happen.
And this really is the core idea. What if the equipment itself could tell us it's about to break before it does? Instead of relying on a calendar or, waiting for a disaster, the machine gives you the heads up. That's a fundamental change in how people and their equipment interact. So the goal is simple, really. It's about moving from a schedule of when to fix to a forecast of what will fail. You're using a constant stream of live data to get an intelligent prediction. So it's not about fixing things because it's Tuesday. It's about fixing the right part at the exact right time, just before it ever becomes a problem. So how the heck does this actually work? How do you predict the future of a machine? Let's peel back the layers and look at the tech that makes these incredible forecasts possible. Well, it really boils down to a pretty simple three-step process: listen, learn, and predict. So step one, listen. Think of rugged sensors as a permanent stethoscope, just constantly listening to the machine's vital signs: vibrations, heat, stress, all of it. Step two, learn. This is where the AI models come in. They sift through this flood of data and find these tiny, hidden patterns that signal something is starting to wear down, patterns that are totally invisible to the human eye. And finally, step three, predict. The system takes everything it's learned and forecasts the potential failure, even estimating how much useful life a part has left. It turns a total guess into a precise science. And the engine that drives all of this? It's machine learning. This is the brain of the whole operation, and this brain is trained on just mountains of data. We're talking thousands of hours of flight time, millions of miles on the ground. It learns to recognize the super subtle fingerprints that a failure leaves behind long before it happens. And the amazing part is, just like a person, it gets smarter and more accurate with every single piece of new data it sees. Now, this isn't just some theory in a lab. It is happening right now on the front lines. So let's take a look at how this tech is actually being used across the armed forces. And we're going to start in the air. It makes sense, right? Modern aircraft generate an absolutely insane amount of data on every single flight, which makes them the perfect place to use this technology. So for aviation, this means listening to the unique hum of a jet engine to catch tiny vibrations that might signal trouble weeks from now. It means analyzing the incredible strain on an airframe during a high-G maneuver to predict metal fatigue.
And it can even spot those little ghost-in-the-machine electronic glitches in the avionics before they could ever impact a pilot's safety.
Okay, now let's come back down to Earth. On the ground, vehicles face just brutal conditions. I'm talking everything from punishing off-road terrain to the intense stress of combat.
So for these ground vehicles, the tech can predict, say, a transmission failure by looking at torque and temperature data, preventing a tank from becoming a sitting duck in hostile territory. Or it can monitor every single jolt and shock to the suspension, making sure those vehicles stay mobile when it matters most.
And what about at sea? The stakes there are just as high. Naval platforms are in a constant battle with saltwater corrosion, and they operate for months at a time. A breakdown out there can leave a crew totally isolated. For the Navy, AI can actually forecast where rust is most likely to form on a hull by combining sensor readings with environmental data. It keeps a constant watch on things like pumps and engines to prevent a catastrophic failure in the middle of the ocean. And this part is really cool. This system can even figure out what spare part is needed and make sure it's waiting at the ship's next port of call. Talk about logistics.
But look, any technology this powerful and this transformative is going to have two sides to it, right? There are some incredible benefits, but also some really significant challenges that have to be managed carefully.
Let's start with the payoffs, because they are massive. First off, readiness goes way, way up. That means more aircraft available, more vehicles ready to deploy instantly. Second, it's a huge money saver. You stop wasting resources and manpower fixing things that aren't broken. But honestly, the most important benefit is safety. By predicting failures, you can prevent terrible accidents and better protect the lives of service members. It's that simple. But it's not all smooth sailing. There are definitely some major hurdles to clear. For one, the AI is only as good as the data it gets. Garbage in, garbage out isn't just a saying. It could lead to a disastrously wrong prediction. These connected systems also become a brand new, very tempting target for cyber adversaries. And then there's maybe the trickiest one, the black box problem. How do you convince a commander to trust a life or death decision from an AI when nobody can explain exactly how the AI came to that conclusion? So, getting over those hurdles requires a really clear, structured plan. This is not a switch you can just flip on overnight. It's a strategic journey. And that journey, that roadmap, really has three key phases. Phase 1 is the foundation. You have to build secure, reliable data pipelines so the AI is getting high-quality, trustworthy information. Phase 2 is deployment. This means using flexible, modular AI systems. Think of them kind of like Legos, so they can be easily upgraded and future-proofed. And finally, the most critical phase, integration. This is not about replacing humans. It's about creating a true partnership between a maintenance tech's years of hands-on experience and the AI's incredible ability to see into the future. And that brings us to a final, really fascinating question to think about. This technology isn't just changing nuts and bolts. It's changing the very role of the people who maintain the machines. They're evolving from mechanics with wrenches into data strategists. So, as our machines get smarter and learn to report their own future, how will our role in maintaining them change right along with it?